Hi, I'm Tommy Mester from data36.com, and this is the second episode of my SQL tutorial series. Today, I will show you the most essential SQL functions that you will use for finding the maximum or the minimum values in a dataset and to calculate aggregates like sum, average, and count. I will also show you some intermediate SQL clauses like order by for sorting the values in your SQL table, group by for running basic segmentations, and distinct to remove duplicates. You have to know these to efficiently use SQL for data science and analytics. So let's get started. Or well, just let me mention that if this is your first time here, this video is the second episode of an SQL tutorial series, so you might want to check episode 1 as well, where I have shown the basics of SQL. And I also have a video where I show you how to install SQL on a remote server, so you can do the coding with me if you want to. Speaking of which, here's a quick comment on how I recommend using this SQL tutorial video so you can learn SQL in the most efficient way. My recommendation is this. First, you go ahead and watch this video. You don't have to do anything, just go through it, watch it, process it. With that, you will see how things work, what do I do and why. And then, step 2, I link the article version of this video in the description, and I really recommend that you continue there. That article lists the full code base that I used in this video, with explanation of course. So after watching this video, I encourage you to check out the article and do the coding part for yourself too. Watching someone code and writing code are two completely different experiences, and if you want to actually learn and use SQL, you should write the code by yourself. Okay, let's get started. Okay, as a first step, we'll log back in to our server using SQL Workbench, just as we have done before. I have already opened the connection window. I will click OK. And we are in. As I promised in the previous episode, in this one, we will work with a bigger dataset. So far, we have this zoo dataset on our data server. It's only 22 rows, so pretty small, and we have the test dataset, which was only for testing. And today, we will start by adding a 7 million row dataset, which is going to be pretty cool. And it won't be too hard because I prepared everything for you. And as I mentioned, we will learn more about how to create a table and how to insert data into it in SQL. But for now, it's okay if you do copy pasting. I linked an article where I show the code base of this tutorial video. So it's okay if you copy paste this. I will actually copy paste this as well. The first command that you will have to run from SQL Workbench is this create table command. Here it is. We will learn more about this, how it works, but what you see here is that I create a new table in my SQL database called fly delays, and I specify the columns and the data types that come into these columns one by one. One line is one column in our new data table. I create the table first. Table flight delays has been created, and if I query this table right now, select everything from flight delays, this is going to be an empty table, right? I have the columns, but there is no data in this table. The next step is that we load the data. And as I said, I prepared this for you. The data is available on one of my data servers, and it looks like this. It's a huge CSV file where we have the same columns that we have just defined in our SQL table, and of course, a lot of data. Now again, you don't have to worry about this too much. You don't have to download anything. You can simply copy the data into this freshly created SQL table by typing the copy command, or well, I actually still recommend that you copy paste this from the article that I mentioned. And again, this will be covered in a later tutorial, but now I will type it. This first line means that I will copy to the flight delays SQL table from program wget from a bash command. And if you are familiar with bash, you will get this. If you are not, don't worry about it. Just copy and paste from program wget -qo https send a tree.eu, which is a website of mine. What's on that? It doesn't matter for now. Well, except if you are a course participant of my 6-week course, the Junior Data Scientist First Month. It's an Easter egg for you, but for everyone else who is doing this tutorial, you will need only one file from this server, the SQL_practicing.csv file. So this line will run a bash command that reads from this server this file and copy the whole content of it into the flight delays data table, into our freshly created data table, and I will have to specify the delimiter, which was a comma in this file, and that our file has a header. And fingers crossed, I hope that this will run. So far, so good. It will take a few seconds because this is a big file. It's a 7 million line file, but hopefully, cool, it's executed successfully. And as you can see, it's 7,275,288 rows that are placed into this table. And let's check it out. What does it look like? And before you run this query, I really recommend that you put the limit clause here, because you don't want to print 7 million rows to your computer screen. It would most probably freeze your computer, but the first 10 rows you can query. And it looks like this. Exactly what we have seen in the file, only that this is an SQL table right now, and it is on your server, or well, actually, because I'm doing this video, it's on my server. And to finalize this process, you will have to type the commit command. We will push this to our server. We committed this new table and the new data in it. And from this point on, the data is on our data server. Select everything from flight delays limit 10. And what you see here is 7 million rows of data of different airplanes in 2007. This is a public data set, and it's perfect for practicing. We have a year column, a month column, day of the month column, day of the week, Monday, Tuesday, or Friday, departure time, arrival time, a flight number, a tail number, air time, arrival delay, departure delay, the origin and the destination airports, and the distance of the flight. If you want to practice a little bit, I recommend that you discover this SQL table. I can actually delete these copy commands, and you can write queries like select everything from flight delays where, I don't know, depth delay is 0, and I will put the limit clause there. And here are a few flights that had 0 departure delay. Anyways, it's time to get started and learn about the different SQL functions to aggregate data in SQL. Okay, I will start with this base query. Select everything from flight delays. I don't need this one. Limit 10. And this returns the first 10 rows of this huge data set. And in this tutorial, we are going to modify this query to get 5 specific numbers. These are exactly how many flights are in our table. The second one is the sum of the air times of these flights. Then the average arrival delays and the average departure delays. Then the maximum distance of any of these flights. And then the minimum distance of any of these flights. And all of these are going to be very easy. And of course, we will have to apply different SQL functions for them. Okay, let's start with the first one. Exactly how many flights are in our table? And the easiest aggregation is to count the number of rows in your table. And this is what the count function is for. The only thing you have to change compared to this brace query is what you exactly select from your table. Again, it can be everything, like every column, or it can be specific columns like air delay and depth delay, for instance. And now let's expand this list with the count function, and we won't select columns, but the result of this function. Let's run it. And the result is 7,275,288. In other words, the number of the rows in our SQL table. The function itself is the count keyword. And here, between the parentheses, we added an asterisk, which means that when we run the count function, we run it on every column. You could actually change this to a specific column, like R delay, and in this case, you would get the very same number, but note that this is only true when in the given column you don't have null values or missing values, in other words, empty cells, because SQL doesn't count the empty cells. We will get back to this later, but for now, we can actually remove the limit clause because we have only one row in the return data. We don't need limit anymore. Or, you know what, let's just keep it there, because if we accidentally want to print the whole flight delays data, we don't want to print all the 7 million rows, because again, that will freeze our computer. This is count, the simplest function that you can use. And the next one will be sum, which will answer this question: what is the sum of the air times of these flights? Basically, we want to get the airtime for all flights added up, and the sum function works with the very same logic as count does. The only exception that in this case, you have to specify a specific column that contains numbers, more specifically integers, and in this case, it's going to be air time. Before I run this, I show you the column that I'm talking about. This airtime column is where we want to sum the values. And by the way, we have a column with a very similar name, which is the OR time, arrival times, but we are looking at the airtime column. We will sum these values, and the result is a huge number. I won't read it, but this is how the sum function works. The next question was the average arrival delays and the average departure delays of the flights. And as you have expected, we have an average function as well. And in this one, we will focus on the depth time and R time columns. First, I will query the average. Oh, sorry, not depth time and R time, or delay and depth delay columns that we will focus on. So it's going to be select average depth delay. This is the first one. And the value is 11.36. And if I replace this, I won't replace it, I will copy paste it with or delay, then we will get the average arrival delay, which is 10.19. That's cool. We can run these two functions in one query, by the way. Just like this. Select average depth delay, comma, then average R delay. This will just print these two columns next to each other, 11.36 and 10.19. We can actually rename these columns because both have the average column name, which is not really practical in SQL. We will learn how to rename columns in the next episode, and this is going to be fine for now. Instead of that, let's answer the next question: the maximum distance of any of these flights and the minimum distance of any of these flights. let's get back to our dataset, and the distance column is the last one, and we want to see the minimum and maximum values in this one. And for that, we have the min and max functions that operate just like sum, average, and count did. It will be select min distance for the minimum value, which is 11. Oh, wow. Well, that's a short trip to get a plane on. Well, maybe take the bike next time, or maybe it's even walking distance. But the other one is the max distance, which is the max function, which is 4962. That makes sense. And so this was it. These are the different functions that you will have to know for a start in SQL. Again, these were count, sum, average, min, and max, and they work pretty simply. Now it's time to tweak them a little bit. And what I will talk about next is how you can run basic segmentation analysis with SQL by using a new clause that we will learn now, the group by clause. As a data analyst or scientist, you will probably do segmentations all the time. For instance, it's interesting to know the average departure delay of all flights. We have just learned that it's 11.36, but when it comes to business decisions, this number is not actionable at all. However, if we turn this information into a more useful format, let's say we break it down by airport, it will instantly become something we can act on. Here's a simplified chart showing how SQL performs automatic segmentation based on column values. The process has three important steps. Step 1, specify which columns you want to work with as an input. In our case, we want to use the list of the airports, which will be in the origin column, and the departure delays, which will be in the dep delay column. Step 2, specify which column or columns you want to create your segmentation from. For us, it's the origin column, and then SQL automatically looks for every unique value in this column. In this example, it's airport 1, airport 2, and airport 3. Then it creates groups from them and sorts each line from your data table into the right group. And then step 3, finally, it calculates the averages using the SQL average function for each group and returns the results on your screen. Of course, it could be any other SQL function, but the only new thing here is the grouping at step 2. And of course, we have an SQL clause for that. It's called group by. And let's see it in action. I will create the segmentation that I mentioned in the example. It's going to be average dep delay. And then I will group by the origin column. And I will have to have this very same column in the select statement as well. I will get back to this in a second, but I will run this query first. This did exactly what I have expected. I grouped by the origin column, and if you scroll through the results, you will see that there are some airports with an average departure delay of more than 30 or even 40 minutes. And from a business perspective, it's important to understand what's going on at those airports. And on the other hand, it's also worth taking a closer look at how the good airports, where the average departure delay is close to 0, are managing to reach this ideal phase. Well, I know this is a little bit oversimplified from this perspective, but just for the example, I think it will work fine. And more importantly, let's clarify what happened here SQL-wise. We have selected two columns, origin and dep delay. I will show you how this looked in the original table. Flight delays limit 10. Okay. So we have selected origin and depth delay, and origin has been used to create the segments with the group by origin clause. And this is not just SMF. I will show you a bit more rows in this table. So it can be SMF, STL, TPA, whatever, ABQ, different codes of the different airports. And then the depth delay column has been used to calculate the averages of the arrival delays in these segments with the average depth delay function. If I go back, this is the result. Just one quick comment here. What happens if you remove this from the select statement? The query will still run, only you won't have the actual origins in your result table, so that is not really preferable. I will just put it back. And by the way, later on you can group by multiple columns as well. So here you can add more columns if you want to. And of course, those have to go to the select statement as well. But for this tutorial, let's keep it simple, and you can actually test yourself. So here's a little assignment to practice and to double check that you understand everything so far. The task is simple. Print the total monthly airtime, and for that, of course, you will have to use a function and you will have to use the group by clause. And I won't show you the solution here, but you can check out the article version of this video where I have shown the query you have to type and the result as well. So check out that article. And actually, here's another exercise that's a bit more complex, because in that one, you will have to apply what you have learned in the previous tutorial video and that you have learned so far in this tutorial video. And the question is, calculate the average departure delay by airport again, but this time use only those flights that flew more than 2,000 miles. And this data can be found in the distance column. Okay, I won't show you the solution for this one either. Again, you can check that out in the article. And let's move on and learn another important SQL keyword, which is the SQL order by, which is there for us to sort the data based on the value of a specific column or columns in our SQL table. Let's get back to our original table. This is it. And let's say we want to see which airport was the busiest in 2007. And you can get the number of departures by airport, for instance, really easily using the count function with a group by clause, something like this. Select count every row from flight delays, of course, and group by origin, for instance. Whoops, what did I forget? Of course, we need origin in the select statement as well, so we can see the name of the origin as well. Here they are. We see more or less busy airports here, but the problem is that this list is not sorted by default. And to have that too, you need to add only one more SQL clause, which is, of course, the order by keyword. And when you use this one, you also have to specify which column you want to order by. And it's pretty straightforward, because in this case, I want to order by the count column in this new table. I will type count. And note that this is a bit special, because the column you will get after the count function will be a new column. And since in SQL every column has to have a name, SQL automatically names it to count. So when you refer to this column in your order by clause, you have to use this new name, the count. But I will get back to this in the very next video, where we will learn how to rename a column. But for now, let's run this. And the table is sorted, pretty cool. Here's the busiest airport. And by the way, if you don't get this, just try out where you order by origin. See, then it ordered by origin. Anyways, let's order by count. And we are almost there because we see the different airports sorted, the different origins sorted by how busy they are. But the problem is that the least busy airport is on the top. In other words, we got a list in ascending order. That's the default for order by, at least in our PostgreSQL database. But you can change this to descending order by simply adding the des keyword, DESC keyword, after our query. And if you run this one, you get the busiest airport on top. If you really want to, you can print only the first 3 airports with the limit 3. Close. There it is. Pretty cool. Okay, there is only one thing left that I want to show you today, and this is the last new thing that we will learn in this video. And actually, this will be a very simple one. For instance, if you are curious how many different airports there are in your table, well, first of all, you can find it by using the group by clause. Can you figure out how to do that? I won't show it to you, but you can do that for practicing. But anyway, there is a better solution, built-in solution, which is distinct, the distinct keyword, which basically removes all duplicates. So try this. Select the origin column from flight delays, limit 1000. And we have duplicate values, of course. And then try this instead, distinct origin. And then we don't have duplicates anymore. Simple as that. And these are all the unique airports. And in the bottom right corner, you can also see that there are 304 of them. But you could also run a count function on distinct. There it is, 304. You know what? I will just show you the group by version. Select origin from flight delays, group by origin. Boom. The very same result. Anyways, the preferred way to remove duplicates is to use the distinct keyword. So this was distinct, and this is pretty much the end of this tutorial. And before I wrap this up, I will give you one more assignment that will summarize pretty much everything we learned so far. So the previous video and this video, and this is going to be a difficult one, but I know that you can do it. And if it doesn't work first, try to break it down into smaller tasks and then build and test your query till you get the result. Anyways, the task is this. List the top 5 planes identified by the tail num by the number of landings at the PHX or SEA airport on Sundays. So, for instance, if the plane with the tail number N387SW landed 3 times in PHX and 2 times in SEA in 2007 on any Sunday, then it has a total of 5. And we need the top 5 planes with the higher total. As I said, it won't be easy, but I know that you can do this. If you want to check out the solution with a detailed explanation, again, you can check out the article version of this video that I linked in the description. Cool, okay. Other than that, I guess that was it for today. We have learned a lot of new things today, SQL functions like min, max, average, count, sum, and a few important SQL clauses like distinct, order by, group by. In the next video, we will continue with a few SQL best practices for data scientists. It's going to be exciting, and by the way, who knows, when you are watching this video, maybe it's already published. And if so, you will definitely find it linked everywhere around this video, top right corner, description, end cards, and so on. Anyways, this is the end of this video. If you liked it, please leave a like, or even better, a comment. And if you want to learn more about SQL, you have quite a few options. As I said, I really encourage you to check out the article version of this video on the Data36 blog and do the coding part yourself as well. I've also created a free SQL cheat sheet that you can download by subscribing to my newsletter at data36.com/newsletter. And if you want to become absolutely confident with SQL, you can check out my 7-day 0 to intermediate level SQL online course as well, where next to the tutorials, I added many tasks for practicing as well. Anyways, thanks for watching. I'm Tomi Mester from data36.com. Until next time.